we're going to be doing in this video is simplifying radical expressions and adding and subtracting radical expressions and making sure our answer is simplified. We are not using calculators in this at all. We've got letters here, so calculator won't help. We're not putting these into a calculator and giving a decimal answer. That is not what you're being asked to do here. All right, let's look at this first. Well, the first thing I'm going to do, since this is a product, is I'm just going to do this. All right, now 48 we know is not a perfect square, but can we express 48 as a product of something that's a perfect square? Well, we know that it's 4 times 12, but 12 itself is not a perfect square, but it can be written as a product of something that's a perfect square. So I think this is the best way we want to write 48 for this problem. So the square root of 48 is the square root of 16 times 3, but now we're going to use the fact that we can split it up. And so instead of square root of 48, we're going to have 4 times the square root of 3. So this is going to be 2 times 4 times the square root of 3. For this guy, we might change that. It's a cubed to the 1/2 power. And so we might go into exponential forms with these. So a square root is the same thing as the 1/2 power. And we're assuming A, B, and C are positive numbers here. So I'm going to have 8 out the front times square root of 3. When I multiply those together, because that's what the exponent rules say, we have A to the 3/2. Then I'm going to have B to the 4/2, which is B squared. And then I'm going to have C to the 2/2, which is just C to the 1st power. Okay. So let's bring that out the front. And now what do we do with this A to the 3/2? Well, obviously 2 is not a factor of 3. So what I might do here is I might rewrite 3/2 as 2/2 plus 1/2. Because we know that's the same thing as that. If I multiply those together, I get that. And A to the 2/2 is just A to the 1st power. So A to the 3/2 is the same thing as that. So I'm going to go back in here and I'm going to replace A to the 3/2 with A times the square root of A. Alright, now I'm going to bring the A out the front. It's a product. I can change the order. I like to put my letters in alphabetical order. And then I'm going to have the square root of 3 times the square root of A. And then the last thing I'm going to do is put those together in one radical. And this is how you would find the answer in a textbook. So that's what they're looking for on something like this. They don't want you to leave anything in fractional form. They want you to put it back into radical form, but they want it to be simplified. And that's what would be expected of us there. Okay, so let's look at this problem. You cannot use a graphing calculator, a calculator of any kind, because you give them some kind of decimal. That's not what's being asked for here. Okay, now you can only combine these if the root is the same. They're all square roots, but the number under the square root symbol, under the radical, is the same. So we can't. Now 45 is not a square root, but I can write 45 as a product, where one of the things in the product is a square root, a perfect square. So that's the same as that, which is the same as that, which is the same as that. So instead of square root of 45, I'm going to have 3 times the square root of 5. So I'm copying this negative 3, then I'm going to multiply that by 3 times the square root of 5. So I'm just replacing square root of 45 with that. What about 12? Well, 12 is not a perfect square, but I can write it as a product where something in the product is a perfect square. So the square root of 12 is the square root of 4 times 3, which is the square root of 4 times the square root of 3, which is 2 times the square root of 3. So instead of the square root of 12, I'm going to replace it with 2 times the square root of 3. So I'm copying this 2, and then for the square root of 12, I'm going to have 2 times the square root of 3. There's nothing I can do with the 6. 6 is 2 times 3. Neither one of them is a perfect square, so I can't do anything with that. Now, what about 20? 20 is not a perfect square, but I can write it as a product where something is a perfect square. So I'll have that. And square root of 4 is 2. So instead of square root of 20, I'm going to have 2 times the square root of 5. So I'm going to have minus 3, I'm copying that, times 2 times the square root of 5. Okay, now I can go to town. That will be negative 9 times the square root of 5. That will be plus 4 times the square root of 3, plus 3 times the square root of 6, minus 6 times the square root of 5. Okay, so I can put those together, and I'll have minus 15 times the square root of 5, then plus 4 times the square root of 3, plus 3 times the square root of 6. No further simplification is possible. To combine these together, they have to have the same root. They are all square roots, but then they have to have the same number inside there. And that is our simplified form, as simplified as possible. And that concludes this video.